Okay, now let's look into the another type of one-tailed test, which is one-sided left-tailed test. For this, we will take a simple example. So, a manufacturer of a migraine headache drug claimed that the drug is 90 percentage effective in relieving migraines for a period of 24 hours. In a sample of 200 people who have migraine headache, the drug provided relief for 160 people for a period of 24 hours. Determine whether the manufacturer's claim is legitimate at the 0.05 level of significance. So that's what is our problem statement. So now we have to formulate the hypothesis. Since the success probability of the drug is P is equals to 0.9, the null hypothesis is P is equal to 0.9. Also, since the drug is either effective or not, testing the drug on any individual is essentially Bernoulli trial with a claimed success probability of 0.9. Thus, the variance of the trial is P1 minus P, which is 0.09, because the drug provided relief for only 160 of the 200 people tested. The observed success probability is 160 divided by 180, which is 0.8. Okay, so we are interested in determining whether the proportion of people that the drug was effective in relieving their migraines is too low. Since P less than 0.9, we choose the alternative hypothesis as follows, which is P less than 0.9. That's the reason this is one-tailed or one-handed, one-sided, left-tailed hypothesis testing, because we will be only considering left side of the distribution. Okay, thus we have a left tail test now. So the standard normal score of the observed proportion is given by 0.8 minus 0.9 divided by standard deviation divided by square root of sample size. So it computes to minus 4.72. So that's what the z standard normal z score of the observed proportion, minus 4.72. So for a left tail test, so now let's see at the 0.05 level of significance, what would be the critical value. So the critical value at that level of significance is minus 1.645, and here that you can clearly see on the screen. So this red flickering zone is our rejection region. So our critical value there is minus 1.645. This is our 0.05 level of significance, and this is the complete rejection region that we have here on the screen. So on the other side, our standard normal z score of the observed proportion is minus 4.72. So this is where it comes. Okay, this is where it comes. It falls under the z score. So the the region left of critical value minus 1.64 is rejection region, and the right of the remaining complete region, right of minus 1.64, is called acceptance region. You see that this is what is called acceptance region. As our since z is equals to minus 4.72 falls within the rejection region, we reject null hypothesis and accept alternate hypothesis, so that is the company's claim is false. Okay, so now let's get back to the code. So this time it's one-sided left tailed test. So for us, let's start writing the piece of code for this, and let's begin with importing the required libraries. Let's import numpy as np, and from scipy.stats import norm. Okay, so let's write a given data from the manufacturer. So sample success, let's take it as sample success is equals to 160, and sample size, as we know, sample size is 200. Sample size is 200. Then we have the population success rate, which is 0.9. That's what we have taken as our null hypothesis. So now let's look into the null hypothesis, and for us null hypothesis is equal to 0.9 and alternate is less than 0.9. That's what we are going to write down here. So let's so our null hypothesis h0 is p is equal to 0.9. This we take it as a proportion. On other side h1, so p less than 0.9. So these are our alternate or null hypothesis. So h a or h naught. Okay, so let's move ahead. Let's calculate the observed success probability first. So calculate the observed success probability. So sample success rate is equal to sample successes divided by sample size. Okay, so this is our population success rate and this is sample success rate, and let's execute. And if you want to see what is our sample success rate, let me print, and sample success rate, it's 0.8, and that's what we got here. The sample success rate is 0.8. Okay, let's move ahead. So let's calculate the standard error first, then we can calculate the z-score. Let's calculate the standard error. So standard error is equal to np dot square root of population success rate minus, population success rate times 1 minus population success rate divided by sample size, and that's what is our standard error. If you want to see what is our standard error, and it's 0.075, that's what is our standard error. So let's move ahead and let's calculate the Let's calculate the z-score now. It's the most important one. Let's calculate the z-score. So z-score is equal to sample success rate minus hypothesized success rate, which is nothing but the population success rate, and divided by standard error. Okay, let's print z-score. Yep. Okay, so we got that. So this is our standard error is 0.021, and we got our z-score of minus 4.714, and here what we see is 4.72, and what we got is 4.714. That's okay, it was rounded off. So z-score has been calculated. Now it's time to mention the significance level. So let's define the significance level. That's alpha is equal to 0.05. Obviously we have gone for the 5%. So till now, with respect to the code, what we did is we have calculated the probability value, and then we have compared with the alpha value, the probability of respective z-score with the alpha value. Then we have come to a conclusion. But this time what we are going to do is we are going to use z-score and we'll be comparing with the critical value. So that's the reason I'm going to calculate the critical value also. Let me keep this at the bottom for now. So critical value is nothing but a z-score with respect to the alpha value. Okay, when the probability is 0.05, what is the z-score? So that's what we call it as a critical value. So critical z-score is equal to norm dot use ppf, and here you'll get just give the alpha value, and what you get is your critical value. If you want to see what is the critical value, you can see that. So critical value, it's minus 1.64. So as we have calculated the critical value, which is of minus 1.645, if you see, this is what the critical value we got it, it's minus 1.64, and as per the calculation with respect to the coding, it is minus 1.645 only. So now what we are going to do is we are going to test it. We are going to test it in two ways. Till now what we have done with respect to coding was we have calculated the probability value of the z-score, respective z-score, and then we have compared with the 0.05. In spite of that, what we will do is first we will compare the z-score with the critical value and we will give a conclusion, and second we will compare p-value with the alpha and we will give a conclusion. So this is similar to what we have done here, exactly what we have done here. So that's what we are going to do here. Okay, exactly. So now let's take up the value. So both critical value and z-score, and then we will write down. So let's perform the hypothesis test. Perform the hypothesis test with respect to the z-score and critical value. So both ways we can do that, but now we will do with z-score and critical value. If z-score less than critical value, then print reject the null hypothesis at the 0.05 level of significance. So the manufacturer, what does it says? The manufacturer's claim is false. That's what we say. The manufacturer's claim is false. On the other side, else print reject fail to reject the null hypothesis at the 0.05 level of significance. So which means the manufacturer's claim is legitimate in this case. The manufacturer's claim is legitimate. Okay, let's execute and see. Okay, so what we got is reject the null hypothesis at the 0.05 level of significance, and the manufacturer's claim is false, and that's what we found here. Here also we have rejected and the company's claim is false. So this is using this, and now we will do with respect we'll perform the hypothesis test with respect to the p-value of the respective z-score and critical and level of significance or significance level. Okay, so here let's change the values, but before that we have to calculate the p-value. Okay, let me calculate the p-value here itself, because we have the level of significance, we have the alpha, and let me calculate the p-value. So p-value is equals to p underscore value is equal to 1 minus norm dot. Okay, let me check whether we have imported it or not. So 1 minus norm dot, let me check this one. Yeah, norm dot cdf, and execute it. So let me print the p-value. Let me print it. Yeah, this is what we got, 1.22. okay, this is lesser, that's fine. And let me check, let me say if p-value is lesser than alpha, then we will reject the null hypothesis and the manufacturer's claim is false, or else it's the other way around. And we got the same response, reject the null hypothesis at the 0.05 level of significance, so the manufacturer's claim is false. And this is how we do. So you can do the same thing with different level of significance. Let's take 1% of a level of significance. What we have done before was with 5% of level of significance, and this time we are gonna do for basically for 1%. So let me paste it here. So let me change this alpha to 1%, and rest all let's keep it same, and let's see what we got it. Okay, let me change this 0.01. so let me change this to 0.01 and execute it, and here we got the same response, because at the 0.01 let me print the critical value also. The critical value is minus 2.33. so let's see in the figure. So minus 2.33 would be somewhere here exactly. So still the z score, the standard normal z score of the observed proportion is still falling in the rejection region from here to here. So that's the reason it got rejected. So reject the null hypothesis at this, and we can apply the same one with respect to the p-value also. Let's see what result it's gonna give. So let me say 0.01, and rest all let's keep it same, and still it's been rejected. And this is how you do one-sided left tailed test.